Greetings, everyone, and welcome to Chapter 3, Lesson 4. We're going to be working on solving multi-step equations. So what we're going to learn today in this lesson is we're going to learn how to solve problems by working backwards, and we're going to learn how to solve equations involving more than one operation, so multiplying and addition, or subtraction and division, or any combination of those. So some vocabulary you want to keep track of is the idea of working backwards, multi-step equations, consecutive integers, and number theory. So the idea of working backwards is one of many problem-solving strategies that you can use, and some other problem-solving strategies are just drawing a diagram, making a table or a chart, making a model, guess and check. Uh, these are all examples of different problem-solving strategies that I'm sure you've done before, but working backwards is the one we're going to focus on today. So the idea of working backwards, right? Let's look at an example. So if I solve the following problem by working backwards, and here's the problem. After cashing her paycheck, Tara paid her father for the $20 she had borrowed. She then spent half of the remaining money on a concert ticket. She bought lunch for $4.35 and then had $10.55 left. What was the amount of the paycheck? So in this instance, you are given the information of how much she ended with and what she did from the beginning, but you weren't told what you started with. So what we're going to do is we're going to work our way backwards. So we're going to start with the end of the problem and then undo each step as we go along. So she had $10.55 left. So that's what we're going to start with, right? There's nothing to undo there. And then she said the last thing she did was she bought lunch for $4.35. So we're going to go ahead and add that back into the original amount, right? Because if she spent it, we're going to add it back if we're working backwards. Next, she spent half of the money on a concert ticket. So again, working backwards. If she spent that much money, we're going to add that back. So if half of her money was spent on the concert ticket, that means we have to double what she had, the $14.90, because that means the other half had gone to the ticket. So if we double it, that'll undo doing half of something. The last part is she paid her father $20. So again, we're going to add that $20 back in, and that's going to leave us with $49.80. Oops. And so that would have been what she would have started that would have been her paycheck, right? Because again, we undid each single step. And again, we started at the end of the problem and we just worked our way backwards, undoing each step to get us back to the beginning amount. So let's look at solving multi-step equations. To solve equations with more than one operation is called a multi-step equation, right? There's multiple parts to it. And we're going to be undoing the operations just like we did in the previous lessons with addition and subtraction and multiplication and division. So let's go ahead and do that. So here's an example. It says solve 7m minus 17 equals 60 and then check your solution. So the first thing I'm going to write down the original equation. And then we would go ahead and we're going to undo the problem. So typically what we're going to do is we're going to get rid of this 17 here by adding 17 on both sides. Then we're going to simplify it, right? So we have 7m equals 77. And then here I have 7 times m, so the opposite of multiplying by 7 is dividing by 7. So I divide both sides by 7, and it leaves me with m equals 11. Now let's double check and make sure this answer works. I'm going to put it back into the original equation. And I'm going to put 11 in for m there. So 7 times 11 is going to give me 77. 77 minus 17 does give me 60. Both sides check out. So the solution of 11 is correct. Let's look at another example. Sometimes your leading coefficient is something other than an integer, right? So we're going to take some steps if that's like a fraction. So here I have t over 8 plus 21 equals 14. So we have to solve it and then check our solution. So here's my original equation. Again, I'm going to start by getting rid of this 21 by subtracting 21 on each side and then simplifying. So t over 8 equals negative 7. Then I'm going to go ahead and multiply both sides by 8 because that's going to be the opposite, right? The undoing of dividing by 8. And so those will cancel out, leaving me with t equals negative 56 because 8 times negative 7 is negative 56. So again, let's go ahead and check it. Original equation, I'm going to substitute negative 56 in for t there, and that's going to give me negative 56 over 8 plus 21. Does it equal 14? Well, let's simplify it. I know that negative 56 over positive 8 is going to give me negative 7, and then negative 7 plus 21 will give me 14. So the solution just check out, right? Both sides end up remaining equal. So 4, p minus 15 over 9 equals negative 6. So now if you notice this, the fraction bar acts like a grouping thing. So we have p minus 5 up here, but all of that is being divided by 9. So I'm going to start with a 9 first, not the 15. All right. So the way that we start with a 9 is that's like dividing by 9. So this whole thing is being divided by 9. So the opposite of dividing by 9 is multiplying by 9. So when I multiply both sides by 9, these will cancel out. And it leaves me with just p minus 15 equals negative 54 because I multiplied by 9 on both sides. Add 15 to both sides, and then I get p equals negative 39. So that would be the solution. Okay, so whenever you have a fraction bar where the whole thing is it acts like a grouping, right? So everything on top is grouped together. So I got to get rid of this bottom part first. I got to get rid of the denominator. All right, so number 5. So here we're going to write and solve a multi-step equation. So it says write an equation for the problem below and then solve it. 2/3 of a number minus 6 is negative 10. So here's my words. I'm going to convert it into an equation now, right? So 2/3 of a number, so 2/3 times n minus 6 is equals, right? Negative 10. So there's my equation. Now I'm going to solve it. I'm going to start with this subtraction right here. So the opposite of subtraction is addition. So I'm going to add 6 to both sides. I have 2/3 n equals negative 4. And then remember with the fraction, easiest way to deal with that is by multiplying by the reciprocal. So I'm going to multiply by 3/2 on both sides. When I do that, these fractions would cancel out here, leaves me with n. And on this side, 3/2 times negative 4. Again, you can make it into negative 4/1, multiply across, and it's going to simplify to negative 6. So that would be the solution. Let's look at the idea of consecutive integers and the idea of number theory. So consecutive integers are numbers that come in order, right? Like counting order, just like 7, 8, 9. So it says beginning with an integer and counting by 2 will result in consecutive even integers. So like 2, 4, 6, those are consecutive even integers because those are all even that come right after the other. If I said consecutive odd integers, that would be like 1, 3, 5, right? Odd integers that come one right after the other. Okay, so when we study these numbers and relationships, it's called number theory, and that's what we're going to take a look at. We're going to take a look at a number like this, or a problem like this. So it says solve a consecutive integer problem. So here it says that we're going to write an equation for the problem below and then solve it. So it says find 3 consecutive even integers whose sum is negative 42. Now, 3 consecutive even integers are 3 even numbers that come one right after the other, right? I don't know what it is, but when I add them up, right, when I add them up, it's going to be negative 42. So I'm going to go ahead and say, okay, n is going to be the smallest even integer. Well, remember, even integers just are 2 numbers right after that. So whatever number n is, my next even integer is going to be 2 numbers more than that. So that's going to be n plus 2. And then the third consecutive even integer would be 2 more than that one. Well, 2 more than that one is going to be n plus 4, right? The original number n plus 4 more, right? So the original number is n, the next one would be n plus 2, and the next even integer would be n plus 4, right? These would give me, no matter what n is, this is going to give me 3 consecutive even integers, one right after the other. So now we have to write an equation that's going to say the sum of all 3 of those, right? So the sum of all 3 of those, where my first one's n, my second one's n plus 2, my third one's n plus 4, and if I add them all together, that's this equation, n plus 2 plus n plus 4 equals negative 42, okay? So then I'm going to go ahead and simplify this equation. And you can see I kind of already did that down there. So n plus n plus n is 3n, and then plus 2 plus 4 is plus 6. So this equation simplifies down to here, and now I can solve it. So if I subtract 6 from both sides, subtract 6 from both sides, and then I would simplify, which gives me 3n equals negative 48. Divide both sides by 3, and I get n equals negative 16. So now I know that n, my original smallest number, is negative 16. So now to find the other 2 numbers, right, I would add 2. So n plus 2, so negative 16 plus 2. So that means the next number was negative 14. And then the other one was n plus 4, so negative 16 plus 4 is negative 12. So my 3 consecutive even integers, whose sum is negative 42, is negative 16, negative 14, and negative 12. Okay, so that one, those are a little bit different than maybe something you're used to, but that's how we do it. Thanks for watching.